everyone, Miss Tui here. Did you know that Ozobot can move at 6 different speeds and you can tell Ozobot how fast or how slow to move? Explore how to draw the speed color codes and watch the 6 different speeds in action. For today's lesson, you'll need an Ozobot fully charged and calibrated, color code markers, a pencil, and your Introduction to Color Codes 2 Speed activity sheet. In today's lesson, you will draw color codes to program your bot to move at different speeds. Observe how your bot changes speed after it follows a color code, and connect the input of a sequence of color with the output of speed. It's true you can tell your bot what to do. You can't speak to it like you would a pet or a little brother, but you can tell it what to do using sequences of color. Sequences of colored blocks found along a black line that gives instructions to your bot are called color codes. First, your bot inputs or receives information from the different sequences of color it travels over. Then your bot processes the instructions and performs an output or action. The color codes you will explore today control the speed of your bot. Speed is the measurement of how fast an object moves. Speed is measured by the rate at which an object covers a distance. You will explore 6 different speeds and watch your bot accelerate. Acceleration happens when an object changes speed, changes direction, or both. To begin, let's look at the speed map. Can you find the color codes key? There are 6 speed color codes numbered 1 through 6. Now look at the path your bot will travel along. There are 6 missing color codes also numbered 1 through 6. You will use the color codes key to complete the pathway. After you put the missing color codes into the pathway, you will need to trace the rest of the line with black marker. I am going to begin filling my map in. The first missing color code is short, super, slow. I will add the color sequence RGB for number 1. The next missing color code is slow. I will add the color sequence RBKR for number 2. Finally, I will use my black marker to trace over the pathway to make sure every color code is between 2 black lines. Can you use the color codes key in your color code markers to fill in the 6 missing speed codes on your map? After your map is complete, you are ready for your bot. You will put your bot on start 1 and observe how it uses the line sensor to follow the pathway and its color sensor to process each color code. Remember, each color code gives your bot a different set of instructions. See if you notice how each color code instructs or programs your bot to move at a different speed along the path. Can you put your bot on start 1? Then watch your bot as it inputs the sequence of colors for each color code and outputs a change in speed. As you watch your bot move along the pathway, did you notice any changes in speed? Were you able to tell when your bot received instructions? Let's watch my bot in action. I will put my bot on start 1. As my bot moves over the color code RGB, the LED light on top changes color to match the sequence. This lets me know that my bot has received the first instruction or program. Next, my bot follows instructions and moves at a super slow speed. My bot continues to follow each color code, increasing in speed all the way to the end of the path. Did you notice your bot was programmed to increase in speed? What are the 3 slowest color codes? What are the 3 fastest color codes? Let's explore the color codes some more. You will put your bot on start 2 and observe how it uses its line sensor to follow the pathway and its color sensor to process each color code. Remember, each color code gives your bot a different set of instructions. See if the direction your bot moves in changes the order of its speed. Can you put your bot on start 2? Then watch your bot as it inputs the sequence of colors for each color code and outputs a change in speed. As you watched your bot move along the pathway, did you notice any differences in speed? 2 of the speed color codes are asymmetric codes that program the bot to perform different actions when read from different directions. Let's watch my bot in action. I'll put my bot on start number 2. Now that the bot is traveling in the opposite direction, color code number 6 becomes RGB and instructs the bot to move super slow instead of a nitro boost. Next, the bot increases in speed when it is programmed by the turbo color code. Then it begins to decrease in speed until it reaches color code number 1. Since the bot is traveling in the opposite direction, color code number 1 becomes BGR and instructs the bot to move quickly with a nitro boost. Did you notice your bot followed the asymmetric codes differently? What speed color codes are asymmetric? What speed color codes are symmetric? Way to go programming your bot to change speed. Make sure your work is complete. Did you fill in the missing color codes on the pathway? Did you run your bot from start 1 and start 2? Can you tell how the speed of your bot changed as it moved along the pathway? Can you tell which color codes program your bot to move slowly? Can you tell which color codes program your bot to move quickly? If you're looking for more to do, you can take your bot on a road trip. On a blank sheet of paper, draw your own pathway and use color codes to program your bot to change speed as it moves from the start to its final destination. Come back again soon for our next lesson.